we have to solve for x for this equation. 2 to the power x plus 4 to the power x is 8 to the power x. We know 4 is 2 square and 8 is 2 cube. And also we know a to the power m to the power n is nothing but a to the power m into n, which can also be written like a to the power n whole to the power m. This is a law of index, formula of index. So applying this, we can write 2 to the power x plus 2 to the power 2 to the power x is equal to 2 cube to the power x. This can be written as 2 to the power x plus 2 to the power x square is equal to 2 to the power x cube. Now if we say 2 to the power x is t, then this equation reduces to t plus t square is equal to t cube, right? So this is t cube equals to t square plus t. Just we exchange the sides. So this can be written as t cube minus t square minus t is equal to 0. So we can factor this. T is common, so we can take t out. So this will be t square minus t minus 1 is equal to 0. So this means either t is equal to 0 or t square minus t minus 1 is equal to 0. We know we can solve any quadratic equation by Sridhar Acharya's formula. And the formula is, for any quadratic equation of the form ax square plus bx plus c is equal to 0, x is a solution, then x will be minus b plus minus root over b square minus 4ac by 2a. So if we compare this equation to ax square plus bx plus c, we can see that t will be minus b, that is minus of minus 1 plus minus root over b square minus 1 square minus 4ac. So this is basically plus 4 by 2. So this will be 1 plus minus root 5 by 2. Okay. Now, so if 2 to the power x is t, then we get either t is equal to 0 or t is equals to 1 plus root 5 by 2, or t is equals to 1 minus root 5 by 2. Now t is 2 to the power x. So basically we get three values of 2 to the power x, right? Now the graph of 2 to the power x, if we plot, this is x-axis, this is y-axis. 2 to the power 0 is 1, and if x goes to infinity, 2 to the power x also goes to infinity. And if, so this is origin, and if x is negative, still it will be negative, and 2 to the power x will tend to 0 as x tends to minus infinity. But 2 to the power x is never 0, and we see 2 to the power x is always strictly greater than 0 for all x belongs to R. For any real number, this is the function of 2 to the power x, and it is passing through 0, 1, and we see as x tends to plus infinity, 2 to the power x tends to plus infinity, and as x tends to minus infinity, 2 to the power x tends to 0, but never 0. So we get 2 to the power x cannot be 0, so this case is getting eliminated, so this cannot be a solution. Similarly, as we know, 5 is greater than 1, so taking positive square root, root 5 is also greater than 1. That means 1 minus root 5 by 2 is a negative number, and we see 2 to the power x never negative, and this value is negative, so this cannot also be a solution for this equation, right? So the only solution that we have 2 to the power x is 1 plus root 5 by 2. Now, so this is not a solution, and this is not also a solution. Okay. So the only solution that we got is two to the power x is equal to 1 plus root 5 by 2. If we take logarithm in both sides, then we get log 2 to the power x is log 1 plus root 5 by 2. Now applying the property of logarithm, this x will come here, so it will be x log 2, and this is log 1 plus root 5 by 2. So we can divide both sides by log 2, so it will be basically log 1 plus root 5 by 2 by log 2. If we calculate this number, this will come as approximately in 4 decimal 0.6942. So the only solution for this equation is 0.6942.